So this is combining what we learned yesterday with what we learned 2 days ago. The first kind of factoring, we looked if there was something in common in everything that we could pull out. So in this one, is there something in common in the 3x squared, the 15x, and the 18? They're all multiples of 3, so we can pull out a 3. And if I pull out a 3 out of the first term, I'd be left with x squared. If I pull a 3 out of the second one, I'm left with a 5x, and finally I'd be left with a 6. After that, inside the bracket, I still have a trinomial, so it might be that what's left could be the opposite of foiling. So if we were going to say, well, I'd still have a 3 here, but now this might be able to factor it further. And what times what is x to get the x squared? Or sorry, what times what is x squared? And the last one's 6, and I need to get a 5. 3 and 2. Plus, plus. Do a quick check. Foil it out. Does it work? Yes. Do the last ones equal 6? The inside and the outside make 5? Excellent. Here we go. What's in common in all three of them? A 2. So if you take out a 2, you'd be left with 3x squared. Take a 2 out of 20, you'd left with 10. Take a 2 out of negative 16, left with negative 8. Now, it might be possible, not always, right? We saw one before that didn't work. But it might be possible that that trinomial was foiled, in which case it would look like this. And what would have to be the first ones? 3x and x. What would have to be the, well, not what would have to be the last ones, but what might work? 4 and 2. Now, if I try a 4 here and a 2 here, my outside's going to be 6, my inside's going to be 4, right? So if I do that, though, and I do one positive, one negative, my outside's negative 6, inside is positive 4. That doesn't make 10. Okay? But if I did 4 and 2 and made, what did I make this one positive last time? Make it negative this time, and that one positive. My outside's positive 6, my inside's negative 4. Still doesn't work. But if I do 2 and 4 instead of 4 and 2, okay? 2 and 4, my outside is 12, my inside is 2. And remember how I talked about this symbol giving us a hint that we're going to have to subtract? So 12 minus 2 makes 10. The problem with 6 and 4 is you have to add them to get to 10. And that is telling us we're going to need to subtract. So if I do my 4 and 2 this way, I make my 4 positive, my 2 negative. Now my outside is 12, my inside is negative 2, and that makes positive 10. It takes practice. This is practice. Did you see that there's a 5 in each of them? And a y. A 5 and a y in each of them. So when you pull a 5y out of the first one, you just get an x squared. You pull a 5y out of the second one, you get a 7x, and a 5y out of the last one, you get a plus 12. And then the inside is a trinomial. So you think foil, or you pull out your set of algebra tiles that you carry in your pocket and start building a rectangle. Probably not. But it's going to be x and x. 3 and 4 plus plus. Outside, inside makes 7. Good job. Okay. Now, yes, you can. Now there are some times where the reverse technique of FOIL that we've been using, that's been our most efficient one, and this technique is going to work great 98% of the time. But there are some times when they are difficult that it's nice to have another technique. If you can't get it from reverse foiling, that you have another technique that works. This technique is called decomposition or factoring by grouping. I'm going to get you to copy down the instructions first. I'll make them a little bit smaller. So that doesn't seem complicated at all, right? Can you still see it at the back if it's this size font? Yeah. Okay, we'll start with that, and then I'll move it down in a bit. On the video, you're going to have to pause it, because I'm going to pause it. Pause again. We're going to walk through this one so that you can see the steps in action. We're going to factor this one using the grouping method or decomposition. What you do first, the first step says, is you multiply the first and the last term together. So we have a 6 as our leading coefficient and a minus 15 as the last. If we multiply those together, we get negative 90. We label that as P for product. The middle term you just write down as a sum. So we're looking for a sum of positive 1. Two numbers that multiply to negative 90. Would you agree that 1 times negative 90 is negative 90? Okay, so one possibility could be 1 and negative 90. However, if I add those two numbers together, what sum do I get? Negative 89. It doesn't match with 1. That's not the right answer. I would hope that your next guess is not going to be negative 1 and positive 90. After realizing the first one didn't make 1, you just thought of switching the negative sign. Like, oh, this one adds 89. I'm still off. But I'm closer. Last time I was 91 away. Now I'm 88 away. So maybe you feel a little bit better. Okay, two numbers that multiply to 90 whose sum, when you add them together, is 1. 3 and 30 makes, now which one do you want to be negative? The 30 negative. Now if I add those together, I'm going to get negative 27. We're a heck of a lot closer than 89. 6 and 15 make 90. Which one do you want negative? And if I add them together, I get 9. We're getting closer. We want to get 1, because we can't do the next step into 9 and 10. Excellent. Which one do you want negative? You want the 9 to be negative, and that gives you 1. That is step 2. You need to find those two numbers. Those are key numbers. Those are the only two numbers that multiply to negative 90 that add to 1. Now that we've found those two numbers, we rewrite the 6x squared. But instead of writing 1x, we write it as negative 9x plus 10x. And we still write the minus 15. Can you see the green is equal to what the green was underlined before? Nothing's changed. So step 1 was to write the product and the sum out. Step 2, and you get more efficient. We were not super efficient here. But you'll get pretty good at finding out what two numbers work. And then step 3, rewrite your middle number as those two numbers that worked. Then you just look at, since we have 4 terms, careful, you might get tempted to combine like terms, but then you'll just get back to where you started. Okay? Look at the first 2. Is there a common factor in the first 2 between 6 and 9? 3. Take it out. Anything else between the first 2? That's a hint because I erased it. 3x. There's an x in the first 2 as well. What would I be left with? 2x minus 3. What could I pull out of the second 2? A 5. So we look at the first 2, and then we look at the second 2. You could pull out a positive 5. And you'd be left with 2x minus 3. If it worked, you will get the same binomial in each one. See how we got a 2x minus 3 in each one. The next step is easier to see if I take out a highlighter. Multiplication joins things together. So this is one thing, one expression, plus this is another expression. It's like yellow plus green. Is there something in common between the yellow and the green? A 2x plus 3. So you can factor that out. Just like we factor out an x that's in common, this has a whole binomial in common, and we can factor that out. That would pull out a 2x minus 3. Well, if I pull out the 2x minus 3 out of the yellow, what would be left? A 3x. And if I pull a 2x minus 3 out of the green, what would be left? Plus 5. Do a quick check for FOIL. Do the first ones equal 6x squared? Do the last ones equal negative 15? Does the outside 10 and the inside minus 9 right? What we've actually done in this step here when we find the 9 and the 10 is we find out what the outside and inside are and write it out. It comes out a little bit different because this is my first, this is still my last. This is actually my inside and my outside are like a little bit switched. And fiol is the same as foil, just doesn't have as nice a ring to it. But this technique figures out what those are, and then because we group these two together and these two together, we call it factor by grouping. Because we break up the x into two different things, breaking something up is to decompose. That's why it's called factoring by decomposition. So depending on what you want to focus on for its definition, that's why it's called what it is. The reason these are good ones to do this type of question for is because if you went to reverse FOIL right away, with 6x, you might have got lucky and said, oh, it's 2x and 3x. And then you would have been right and it wouldn't have been too hard. But it could also be 6x and 1x. There's more than one choice for that first one. And if you choose the wrong one, you try for a bunch and none of them work, then you'd have, oh, I have to try the other one. And sometimes there can be a lot of options. So on ones that start with a number or end with a number where there's lots of options for both, this technique sometimes is faster. The reverse foiling might still have been faster in this one. Let's try another one. Again, this is a good example because 4 could be 2 and 2 or 1 and 4. So product of 36, sum of negative 15. We figured out negative 12 and negative 3 are what would work. 4x squared minus 12x minus 3x plus 9. Did anybody write it the other way? Put the 3 first and the 12 after. Okay, I'll do that after down here. It'll give you the same answer. It just will be a little bit different when you group them. But it's important to know that it doesn't matter which order you put them. It'll work out to be the same. So you don't have to feel like, oh, did I do it wrong because I had them in a different order. On the one here on the left, when I look at the first two terms, what does it have in common? 4 and an x, leaving me with x minus 3. Now, earlier, a couple days ago, I'd said there was a question where we could have pulled out a 3 or we could have pulled out a negative 3. You remember that question? I said either one is fine. There will be some cases where we'll want to pull out a 3 and some cases where we'll want to pull out a negative 3. Now here, we want to get the binomial to be the same in the first and the second one. So if I want to get a positive x, I'm going to have to pull out a negative 3. And that'll leave me with x. And negative 3 times what is 9? Negative 3. Again, we can think about our highlighter, the second one being the green one, first one being the yellow one. We've got a yellow term minus a green term. Do they have something in common? Yes, they do. They both have an x minus 3, so you can pull that out. What's left in the yellow one? Just a 4x. What's left in the green one? Minus 3. Now, had you done it sort of in the bottom right-hand corner here, had you done it this way, now the only thing in common in the first two is an x, leaving me with 4x minus 3. And what's common between the 12 and the 9 is a 3. I'll want to pull out a negative 3, so I get 4x inside, and I'll be minus 3 as well. What's in common in the two terms is 4x minus 3. What am I left with in the first one is an x. What am I left in the second one is a minus 3. It's the exact same answer, just in a different order. Now, factor by grouping works even with ones that'll be easy to do the old way. That's what the little star is there for, just to tell you, whenever possible, use the old way because it's quickest. If you had to FOIL that, what has to be first? X and x. Good. To get a 36 and to get a minus 13. No, not 3 and 12, not 6 and 6. 9 and 4 make 13, good. And they both have to be negative to get the positive 36. So this is how I would recommend doing a question like this one, because that's the quickest. However, I'm going to show you that it still works. The product of the first and the last, well, there's a 1 out front, right? 1 times 36, our product would be 36. Our sum would be negative 13. What are the numbers? 9 and 4, both negative, right, in order to make the negative 13. And so we could write x squared minus 9x minus 4x. Oops. First two, I could factor out an x. Next ones, I could factor out a negative 4. We get x minus 9, x minus 4. That's a lot more work and a lot more writing than the original way. Okay? Again, as the tool, later on in mathematics, you'll be solving questions where you've got 3/4 of a page of mathematics as your work, and factoring will be like little lines here and there. So it does make sense if you can do it directly, because it'll take up less room in your work. We'll get to some of those this year. Some simplifying questions where you might have to factor 6 times, 6 of these in one question as part of the simplifying. Okay. Another one that, because this is a prime number and you only have one option for the first one, this makes it a good one to do using the old technique. I will show you one that is nasty with both techniques, but where the decomposition technique is probably the fastest. Okay, but if I'm going to get 2x squared, what has to be here for the first ones? 2x and x. And to get a 5, it can be 1 and 5 or 5 and 1. Which is better, 1 and 5 or 5 and 1? Notice how I hesitated both times. Now you don't know which is right and which one's wrong. All right, so if we do 5 and 1, outside will be 2, inside will be 5. Does that make 11? It's going to be 1 and 5. Because now my outside is 10 and my inside is 1. Okay? The nice thing about the product and sum method or the grouping method, okay, multiply the first and last, product is 10, sum is 11. What are the two numbers? 2 and 5? That works for product but adds to 7. 10 and 1 works for the product and it adds to 11. Excellent. So let's circle that one. That's the right one. So we have plus 10x plus x plus 5. And I have this example in here because when we go to factor this by grouping, something kind of weird happens. In the first two, everything's good. You're feeling really good. I know how to do this. I can take out a 2 and I can take out an x. It's 2x, leaving me with an x plus 5. Then you get to your second one and there's like nothing in common. So what do you take out? You could do that, put it in brackets, or you could put a 1 here as well. Well, it might help you when you do the next step, right? Because the next step is saying, I take out an x plus 5. What's left here? 2x. What's left here? Plus 1. Well, you wouldn't need that 1 there, but it's kind of a nice example to see because there was nothing to factor out of that second one. Here's your homework and here's your challenge question. Factor by grouping. (16x squared plus 17x minus 30. We'll put the answer up for that one. I really liked Stephen's technique. Another thing you can use as a technique is you can just break up 480. You know it's probably 48 times 10, right? 48 is 6 times 8, and 10 is 2 times 5. And then 6 is 2 times 3, 8 is 2 times 2 times 2, and we still have 2 times 5. That's our prime factorization, right? So we could do the prime factorization of 480 and then just start combining different things. How many different combinations could you do? Right? You could combine these together. 2 times 2 times 3 make 12. So 1 could be 12. And what am I left with? 2 times 2 times 2 times 5 make 40. 12 times 40 make 480 as well. Eventually, with combining them, you'd think about putting the 3 and the 5 together, giving you 15, and the other 5 2's would make 32, and then you'd find your 17. It would take some time, though, of guessing and checking which ones to go together. What I like about Stephen's technique is he stole from one and threw it on the other one and sort of worked back and forth until something worked. Well, once we got the 96 and the 5, 96 divides by 3. So if I throw the 3 over here, I'm going to get 15. But then I have to take 3 out of this, leaving me with 32. It's pretty cool, eh? And that can be a very important strategy for factoring too, because, for example, if you have something like 48, you might see 6 times 8 right away, because that's part of your times table. But now I can take a 2 and put it over here. Maybe you don't see 3 times 16 very quick. That's the one people see the slowest. But once you have the 6 times 8, you can get the 3 times 16 quite easily. Okay, anyways, we go here. We can take out a 16x, leaving us with x plus 2. And out of here, we can take out a negative 15, leaving us with x plus 2. So this factors to x plus 2 times 16x minus 15. And the reason I chose this one is most people would not choose 16x and x as their first choice. People choose 2 and 8 or 4 and 4 more often. So